Hey everybody, UT is doing awesome this year at football. Just my shirt is, I've never worn this shirt on camera because it is like a lighter green. It's like a teal with green, and the text. Today I wore it and I was like, because there's shirts I can't wear because they have green. And I was like, let's just see what happens. If I'm a floating head on screen, hey, I'm a floating head on screen. That's the way it goes. So let's see who's here. We're logging on to my Pearson. A little chill music to get us started right here. Let's play this one and then we will get things loaded up. So I'm loading up my Pearson because probably people want to do my Pearson. Probably. I don't know. We'll find out what you want to work on. We'll see what assignments are coming up. But if you're here live in the chat, maybe I'll send out some video. I'll say, hey, who's here? Let's see. It cuts off my music. I think you can still hear the music. I'm gonna restart the music. My whole setup is weird. Oh, I don't get to hear there's my music. If you're here in the chat, feel free to say hi, and we can do whatever you want to work on. Maybe I'll say on Discord. I'll go over to Discord and I'll say, hey everybody, we're live on YouTube. We're live on YouTube. Oh, step one. So we do chapter 4 this week. Yeah, definitely. We already did chapter 4. Join office hours and work on it if you want. Okay. Maybe I'll miss a stand 201 to say office hours are live. Office hours are live. On assignments. Start of the week. Get more work done. Some people are saying. Got so many things open right here. I need someone here to do work. I'll pick what work we'll do here in a moment. What work shall we do? Okay, statue 1. Send that reminder. Just say office hours are Monday through Thursday. Online. Online office hours currently live. If you're here, remember Mubot. Say hey to Mubot. Office hours currently live. Click here. Office hours online are 10 to 11 on Monday through Thursday. Look y'all. Okay. That's the link. There's the link, and I don't get to hear my music, and now it's back. Office hours currently live. Who is here? I'm almost done saying announcements. I'm gonna do chapter 4 homework. Chapter 4. Hey, Nima, good to see you there. Remember, we can do any assignments you want. Mubot's already saying hi. I want to hear this one step. Any assignments? Chapter 4 homework? That is a great idea. That's what I was kind of thinking about doing. I like that. It's a very good idea. Let's do all of chapter 4 homework. All of chapter 4 homework. Not due for a little bit. September 10th. Oh, it's due coming up here soon. It's a good idea to do it, right? This is it. It's not too many questions. Aaron, good to see you there. Look at this. We got a bunch of people here now. Mubot saying hey to everybody. Okay. So now we're going to mark in the notes. Where are the notes? Video details. And Mubot's already there. Okay. We got 503 and we got chapter 4 stat 201 chapter 4 homework question 1. Let's go do it on the main screen. Okay, we are pulling up the first question right here on chapter 4, and it says the Research and Innovation Technology Administration of the Bureau of Transportation Statistics reports load factors. Passenger miles as a percent of available seat miles for commercial airlines for every month from 2002 to 2019. Jaden, good to see you there. Thank you so much, Jaden. We'll throw you some points, and good seeing you today. Here are histograms comparing the distributions, and let's take a look. So what is chapter 4? Chapter 4 is comparing distributions, and you can see here these both are what skewed. What skewed are these distributions? Both these distributions are what skewed. Both of these distributions are what skewed. Answer in the chat. Yeah. I know your stats. Both of these distributions are what skewed. Left skewed, left to the low. So remember, left to the low, right to the high, whatever way the Monster Man's tail goes, more points in the chat. We'll see what they ask here in a moment, but since they're both skewed, what should we compare for the distributions? So remember, there's shape, center, spread. This is a bit of a review of a lot of topics right now, because these are the measures of center. These are the measures of spread, and you should know that standard deviation and IQR versus mean versus median, and we should compare. Jaden's already got those points. Elizabeth, good to see you there. So Jaden said for center, we should compare median. Boom. We got a stats pro in the chat. Median if it's skewed. Jaden knows right there. And then for spread, what should we use? And they actually kind of put them in order. So for spread, what should we use? We're not even looking at their questions. We're seeing if we can do it without kind of using their guidelines of what they want us to answer. We'll answer the questions, but we should know if it's skewed, you compare medians between distributions, and these are both left skewed. And then what is the measure of spread? Boom, IQR. Aaron's got it right there. You got it. So there's the IQR. We can see which ones are more spread. So we can make comparisons for the center and spread respectively. And we know the proper measure of center and the proper measure of spread. Great job, Aaron. Let's see what they ask. And they're going to probably ask things like this, and we'll try to answer it. Choose the correct answer below. Both distributions are left skewed, so it's got to be one of these right here. The medians are very similar. The medians might be similar. Let's take a look. They're off by 3, and the IQR is off by 1. So that's not going to help. Medians are similar. The IQRs showed that the international vary a bit more. No, the domestic vary a bit more. You see, domestic has a larger IQR of almost 7, and that's 5.7. So it should be the domestic loads vary more. And I'll show you how I saw that again. Once again, so that's an easy question. But we can see here that domestic has a larger IQR, and they're doing the right thing by comparing medians to medians and IQRs to IQRs. So a little short question right there. We got it. Frankly, if you know it's left skewed, you get multiple attempts. So frankly, just looking at the skew, you can get it right. Once again, I try to tell people do the work and know the topics, because if it's multiple choice, we narrowed it down to 2 and you get 2 attempts. So hey, that's all I got to say. This one's a bit interesting. We'll mark it down. What is this graphic we're looking at, and what kind of data does it display? So you should know what the name of this graphic is, and you should know what kind of data it displays. What is the name of that graphic there, and what kind of data does it display? So what is the name of that graphic? What data does it display? What do we call that graphic? So you should have a note. This is a blank. It displays blank, blank data.
Wow.
Like my buttons. Oh, no one knows. No one knows. Remember, have this all marked here. We're in this quadrant up there, that top left quadrant, which is univariate quantitative. So what is that graphic called right there? It's a box plot. Nima, you got it right there. That is exactly right. That's a box plot. Box plots display the 5-number summary. These are things you should know. Like as I say them, be like, oh yeah, box plot displays the 5-number summary. And you can see you have the min, the Q1, the median, the Q3, and the max. Those are the components of the 5-number summary. So whenever you look at a box plot right here, you want to realize that the min is going to be this line right here. The Q1 is going to be the start of the box. The median is going to be a line that's usually visible unless it overlaps with other quantities. The Q3 is going to be the top of the box, and the max is going to be the highest point. Do not forget outliers. If you forget outliers, you're going to forget calculating them as part of the range. This is a rather large range. You must remember outliers when calculating range. Outliers greatly impact the range. So the IQR, which is a range of the middle 50%, the interquartile range is not impacted by outliers, hence why we like to use it when there's skew or outliers. And this is right skewed data, because you've got a lot of the data over there on the left side of the data, and you got Monster Man with his tail going towards the high side. So a lot of the data is kind of centered around the peak or the box of the box plot, because 50% of the data would be contained within that Monster Man component, because that's where the box plot is I do horrible drawings right here. But that box has the majority of the data in it from 20 to 25, and then there's a skew pull to the high side, it looks like, especially with the maximum. So what should we say about this? Should we remove the electric car? That's what this car is up here. It's an electric car that has insane mileage. And the answer is maybe. Thank you. Yes, Jaden, seriously. So I'll add that to my list of PhD students telling me it helped. Now I have students with internships telling me it's helped. It's easy to remember right to the high, left to the low, whatever the way the monster man's tail goes. And then you never forget how skew works, because it's easily just to confuse it. You have to always give outliers what attention. Outliers always deserve our what attention. They always deserve our what attention. Every single outlier ever, before you toss it out, if you do, because you can toss them out. Good morning, Bailey. Outliers deserve our special attention. We're doing chapter 4, question 2 homework. They deserve our special attention. And so with that, if we removed this outlier, it would make the data what spread out. Removing that outlier, would it make the data more spread out? Or when you remove it, it would be less spread out? If you remove the data, if you remove that point, the data would be less spread out. And standard deviation is a measure of spread. So the standard deviation, or how much things deviate from the mean, would get wetter. You're on the right track now. So removing the outlier would make the data less spread out, because there's less data spread out. I mean, that's what we're saying. How spread out is the data? Let's take the far away one, and it's more compact now. So it's a measure of spread. And so standard deviation would what? Removing it, if we should, which we could say, let's just not talk about electric cars. Standard deviation would get smaller, exactly, because it's a measure of spread and how much things typically deviate from the mean. So the standard deviation would get much lower. Standard deviation is the sum of the squared differences. They get into some of the calculations right there. I'll hover over it so you can see it again. But it talks about the formula, which, so I went a little quick because we don't test you on the formula. The formula is the sum of the squared distances of the observation from the mean. Well, frankly, you could do reverse. Doesn't matter. It doesn't matter! Because you're squaring it. And then you divide by n minus 1, and you square root it. So what they're saying here is the squared differences, the sum of the squared differences. And that's what this says right here. Standard deviation is calculated by summing the squared differences. And you look at the formula, you're summing the squared differences. So it doesn't matter which way you subtract them. How will this impact the IQR? Let's have a great note. You ready? And Aaron, we're throwing you 500 points. Aaron already gave the answer, and I love that, because the IQR is not impacted by outliers. Does that make sense? We can even see this if we go into jump right here. Let's load up jump real quickly and make a data set where we have points, and then we put in the last point right here is ridiculous. And now we go here to analyze distribution. You don't have to make this data. I'm just showing it with data. The IQR for this data is what? It might be a little odd to calculate. Tell me the IQR for this data. Who can tell me the IQR for this data? Tell me the IQR for that data. So once again, really good practice to know what the IQR is, the range of the middle 50%, and see if you can see the IQR. The IQR is 75 to 25, the percentiles. It's a weird number. It's not a perfect one. What is the IQR? 5.5, Bailey, perfect answer, 200 points, you got it. And so these also count for the asynchronous or online, so you're getting points. We'll look at them at the end of the semester, keep getting points. So you can see here, you just subtract these numbers to get the IQR. The standard deviation is 31,000. Let's see what happens when we remove this point. So now I'm gonna go here to hide and exclude, and look at that. The IQR is basically the what? It was 5.5, and now it's even easier to calculate. The IQR is basically the what now? Now it's 5. It's basically the same. The standard deviation was like 31,000, and now the standard deviation is 2.7. So the standard deviation drastically changed. Does that make sense? When you hide or exclude this outlier, the standard deviation goes down from 31,000 to 2.7. So outliers drastically impact standard deviation. They don't really impact because they're a positional thing. They might change the IQR, but only not much, if any. So the IQR really wouldn't change much. It would not change very much, if any, because outliers don't impact the IQR. They really don't. They change positional areas, but not really much. So it would be the same if it was the top point, because it's just, yeah. Is the standard deviation always the same as the median? Good question, Aaron, right there. Let me just elaborate. The standard deviation and median are two completely separate topics. The standard deviation right here is a metric of sum of squared distances from the mean. The median is the 50th percentile. Does that make sense, Aaron? The standard deviation is a completely different topic that goes with the mean. So the mean is the average. The standard deviation is a typical distance from the mean. The median is the 50th percentile. The IQR is the range of the middle 50%. So remember over here, you have mean and standard deviation. They go together as center and spread for normal data, and median and IQR go together for center and spread respectively for skewed data. And they're completely different topics. So good questions. Boom, I like this right here. How does this work for mean and median? I know when we use median for the skewed data, not mean, but I don't understand why. Okay, so imagine this. You're going to go work for a company, and this is a really good elaboration spot. And the company says the median salary at the company says the median salary at the company is $120,000. What does this mean to you? What does this mean if the company says the median salary at the company is $120,000? Just explain to me what that means. And Jaden's got great answers right there. What does it mean if the company says the median salary is $120,000? Just explain to me, what does that mean? What does that mean? And Jaden's got good answers there. What does it mean if they say the median salary is $120,000? Yeah, it's right in the middle, right? So that means like half of the people at the company make more than that, half of the people make less than that. Does that make sense? Like if it's a 1,000-person company, about 500 people make that or more, 500 people make that or less. Don't worry if it's like, would it be $499 or it's like about half make that less or more. It's like half on either side of that. So that's what the median means. If they say the average salary at the company is $120,000, now they're saying if you add up everyone's salaries and divide them, then you would get $120,000. So what if we look at right here, where the salaries at this company, let's see, trying to think. I'm going to put it to 200,000 because it's easier for me to do fake numbers with. Oh, no, we want $1 million. Okay, that's $1 million. There's 5 people who work at this company. 4 people are being paid what? There's 5 people who work at this company and 4 people are being paid what? There are 5 people who work at this company and 4 people are being paid what? $0. So since we have them in order, the median salary at this company is $0. Does that make sense? The median salary is $0. But now the average salary at this company is how much? The average salary at this company is what? The average salary at this company is what? Because you could just do, it's $1 million and there's 5 people, 200,000. So now think about this. If you were to work at this company and you hear there's a boss with 4 workers, what better represents the data? The average salary at this company or the median salary? What better represents kind of what to expect at this company? You would say, well, if I'm going to go work at this company, I'd probably expect the what salary? What would you expect? What salary would you expect? The median or the average salary? Which salary would you expect? The median. And it's because outliers greatly impact the mean. So when there's outliers like extreme values, they impact the mean and make the mean unreliable because then the mean is getting pulled in that direction. So if you have a company ripping everyone off and it's like, well, one person's getting paid $1 million. If you say the average salary is $200,000, well, no one's getting $200,000. One person's getting $1 million. So when there's outliers, they greatly impact the mean. And that's why we don't use the mean when there's outliers. We use the median. And then mathematically, the median is very much like how we calculate the IQR. It's based on percentiles. So the median and the IQR go together because they're percentile based. And then the formula for the standard deviation is actually using the mean. So when we say how much do things standard deviation is from the mean. Like how much do they standardly deviate from the mean? Does that make sense? So if we have data that's not skewed, you can technically use either Bailey, great answer right there. Then it's kind of a, it doesn't matter. But if data is skewed, it matters. So Bailey, really great comments right there. You can, when data is more normal, you could just do whatever kind of. We use mean and standard deviation more commonly, and I would do that for the test. And then when data is skewed, don't use the mean, don't use the standard deviation, because the standard deviation is calculated off the mean. So if the mean is kind of unreliable, the calculation for standard deviation. Exactly. And really great comments from everybody, really good comments and good understandings. So kind of the quick memorization is when data is skewed, use the median and IQR for center and spread. When data is normal, use the mean and standard deviation, but it doesn't matter. But for the test, use mean and standard deviation. Really good comments, really good questions, and thank you everyone. We'll do, and please keep asking them. I can do elaborations, I can do reviews, and we can finish off this homework right here. It's your office hours, it's your time to get things done. Down here, it's our time. We got a lot of time. Okay, so 22, 23, stat tool 1. I feel like those are the most informative moments, and then people just skip through. They're like, I got to get to this next question. It's like, well, if you learn it, then you can answer it. Okay, so this is load factors again from 2002 to 2019. Let's take a look at the visualization. These are called whats. These are called whats. What is this called right here? What by whats? It's a bivariate visualization somewhere in here-ish. You'll see the names. Just a bunch of them side by side. What is this called? What is this graphic called? Someone once said, what are those? What's that graphic called? Let me get my zoom back. Side by side box plots. Yep, it's just box plots side by side. And you can see kind of a trend going through here where the middle months have a greater spread. Now, if you were to, I need to get my zoom back in. Which of these months, and give a number, probably has the greatest range? And this is a very good test question. Which of these months, and it is a toss-up, there's wrong answers you could say, but which of these months, give me a number, looks to have the greatest range? Great job, Bailey and Nima there, and Aaron. Which of these months looks to have the greatest range? There's, don't worry, this wouldn't be a perfect test question, but there's wrong answers to be had here. Which of these months looks to have the greatest range? Don't worry if you're wrong. I'll show you why, and it's a common mistake people make for the test. April, January, February, March, April. Yes, yeah, double check it right here. Probably, and good to see you there, Jackie. April looks to be a good contender. So what's the note to remember? So when looking for greatest range, do not forget what's is. When looking for greatest range, do not forget what's is. These would be wrong answers. When looking for greatest range, do not forget what's is. Because I think April's a good contender. Huge note to have, remember for the test, when looking at box plots for greatest range, do not forget to look for outliers. You got it right there. Everyone knows. And so, because you're here, you're practicing, you won't get that wrong on the test. There are questions on the test that say exactly that. So let's see what they want to know. Once again, it's a multiple guess, but let's do it. Load factors are generally highest in the summerish months. So that's around here. So we're probably fine to just say that. And then we're probably good. Yep. And then there are more variability in the winter and spring. They're talking about winterish months right here, and spring, I guess. Yeah, this is the variability they're talking about. Once again, all you have to notice is the highest and the median is the trend we're looking at. So the higher medians over here in kind of September or August in those areas. Are outliers ever shown by using a dot? Yeah, so a lot of times this is an extreme outlier, more than 3 IQRs below Q1. So a dot is 1.5 IQRs and a star is 3. You'll just see them usually as, like if we go Google Boxplots, they'll always be outside the whisker. So if we look at Boxplots really quickly over here, they put a, let's see here. So you can see ones like there's an outlier there. And so they're always just away from the rest of the data as a dot. I don't like how that one looks. There's the normal curve. There's outliers right there. You see they're doing the 1.5 IQRs. There's outliers right there. Exactly. Really good comments. And Jaden's right. Depends on which type you make, because sometimes we'll make different ones. There's a box plot right there. Ooh, that is not visually correct, because you can see that's not 1.5 IQRs. Sometimes we'll make them a little bit differently, but there's the outliers right there, and there's the histogram. Yeah, so there are different ways to make them. Yeah, and then introduction to box plots, and then they grouped them differently there. So really good stuff, really good questions. And there's an outlier right there in Excel. So yeah, just the dots are the outliers. So when you see a dot, you know it's an outlier, like outlier, 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 outlier down there. And sometimes they do like a star. It'll either be a star or dot, but it'll be outside the whisker. Really good questions. And let's do the next homework one here. Okay, it's just general knowledge of box plots. It's gonna take me more time to enter in. It's gonna take me more time to enter in the note than it is to do this one. What do box plots show us? What do box plots show us? Doing this one from memory right now. Box plots show us the what? What is shown to you in a box plot? What do you visually see in a box plot? It is a visualization of the what's. A box plot is it's univariate. I like that. It's univariate quantitative. Yep, Neiman's got it right there. Pulling up the notes. It's univariate quantitative, a visualization of the 5-number summary. And you can see right here as we go through the notes in the 5-number summary. Yep, it's univariate quantitative visualization of the 5-number summary, and lets you see where the outliers are. We can also use like a histogram below it to show. Sometimes it gives you the mean if they do the extra thing, which Jump does by putting a diamond. Also a 95% confidence interval for the mean. That's a little more extreme. We don't need all that. We just need to know a box plot is going to show us a center line for the median, which is part of the 5-number summary. So once again, know that if you look at a box plot right here, this center line right here, this is the median, just showing you what value the median is at. Here we'll go side by side on this. So that is the median. And what else next? The center half is, there's a center half to it. That is known as the IQR. And that is the box of the box plot right here. The IQR, this, make this bigger so you can see these numbers. But you notice 2.28 to 0.46. That is the top and the bottom of that box. So the center is the middle 50%. That's true. Boxes are great for comparing 2 or more groups, and the answer to that is definitely yes. We could make multiple side-by-side box plots. 2 or more groups are being compared right here, and the values which are displayed by a dot or an asterisk are outliers, and you see that right here where we can make dots or asterisks as outliers, and very much true right there. So really good stuff. Yep, dot or asterisk is going to be an outlier, and just understanding the basics of a box plot. So good stuff. Just make sure to review and look at the notes for that. Not too bad. Are people getting this homework done? We are almost done on this homework. This is probably one of the easier homeworks before we get to chapter 5.
Chapter 5.
The demon voice was so low that it was so scary. I couldn't even understand myself in the video from class. I was like, wow, I gotta increase that a little bit. So chapter 4 homework, question 5. Here we go. Once again, this technology place doing monthly load factors, and we got side-by-side box plots. If you notice, there's a trend. This is 2002 to 2019. They just remove the first part of the year. And you can see kind of a flow nature to it where it goes up. You can also see there's less variation in the data because the mins to the maxes are getting a little bit tighter. And you can see it was tighter towards the end. And so let's see what they want to know. I don't love this question. So air travel immediately after extraordinary weather events was not typical. Air travel after extraordinary weather events was not typical. In order to analyze monthly patterns, it might be best to set these days aside. I've never liked this one. In order to analyze monthly patterns, it might be best to set these days aside. Well, I would say after extraordinary weather events, air travel is not typical because they're saying blizzard dumped in the year 2020 and we don't see it, or we don't see it because it's monthly, and so we might have outliers. And so this is like one of the worst questions I've ever seen. That's a bad question. What they're getting at, have you gone through, we get chapter 4 quiz. Yeah, Jackie asked whatever question you want. We just did the homework. What it's saying is right now this data is yearly, and they're saying you should make it monthly data to see at a more granular level what's going on, like month by month by month. And then you would see like the disturbances, because right now the data is all cluttered within the year. So when you see like one point right there, that's just unusual within that year. But if we were to break it down by like month data, then we would see like, oh, this month had a bunch of weirdness going on. And it's just how you make your box plots, just a bunch of side-by-side box plots. When you have a very large amount of data, more than would be applicable in side-by-side box plots, and want to look at the median, there are box plots alternatives. Yeah, like histograms, exactly. Chapter 4, research and innovative technology. Guys, this place does everything, right? Let's go do that question. Let's just research. About what question is that for you on the quiz, Nima? What question is that? And I'll try to find it in the order in which it is. Like if it's an earlier or later one. Is it like question number 2 or 3 or 1? Replace questions. Oh my gosh. I'll show you all the questions I have. Here's all the questions I have. Is it this one? Is it this one right here? Tell me yes or no in the chat. Is it this one? A lot of questions. Okay. So I want you to look at the graphic, and I want you to tell me where the box plots are the highest. Where are the box plots the highest? Oh no, this is left skew, right skew. So is this data left skewed or right skewed? Is this data left skewed or right skewed? Right to the high, left to the low, whatever way the monster man's tail goes. What way skewed? It's left skewed, exactly. So since we know it's left skewed, we've narrowed it down to 2 choices now. We got this, we got this. And now it wants to know which ones vary more. So it's basically asking which one is more skewed. To say which one varies more, which of these is more skewed? Is April, August more skewed, or is September, March more skewed? Which of these is more skewed? Which of these has a bigger monster man tail? Which of these has a bigger monster man tail? Would be the top or the bottom one? Which of those is more skewed? I need a rebel today. Which of those is more skewed? Actually, and maybe I'll be wrong, but and if we look here, this goes, they both have the same scale, same horizontal scale. The bottom one looks to have a bigger tail to it. Like, if we put everything to the same distribution, the longer the tail, the more spread out it is, the more it's like pulled in a direction. And this has like more centrality in this area. And if you notice, it gets more skewed if you think about where the middle 50% is. So it gets more spread out. So it's probably April, August. I could be wrong. I'm starting to doubt myself. So April through August is the spring and summer. So, right? Am I wrong? Oh my gosh, I was wrong. Fall and winter. I just might have my months wrong. Let me see here. I'm saying it's the bottom. September through March. Let me double check. The fall and winter loads appear to vary more than the spring and summer load factors. Fall and winter. Fall and winter would be... It is saying that one? Well, it goes... They might just be going by range. They're probably going by range. Yeah, I got one wrong today. Let's throw 1,000 points because Brian was wrong, and I think I see why. I wish I just had the IQR. So everyone was right in the chat who said the top one, and here's part of the reason too. If you look at the range of the data alone, it stops right there. Does that make sense? So even though this has a bigger Monster Man tail, it doesn't have as big of a range. So this is this Monster Man tail, this is this Monster Man tail, and it does have more skew to it. It is still more skewed. I just drew it out too far. It only goes down to there. Didn't love the question, and here's the thing. If I just had the numbers, I could just look at the IQRs. Does anyone remember that question we had just a little while ago that showed us the IQRs? Then you just look at the IQRs, and if you look at the IQRs, you know the answer. So really good job right there, 1,000 points. I got the first one wrong of the day, but I got a multiple guess on it. I know it's left skewed, and they're going by range-ish, and then IQRs might have been similar because of the skewness of it. My Pearson, not today. Which one should we do next? Which one should we do next? So this is the right answer right here. Fall and winter do vary more. And I wish they didn't say fall and winter. Then I got to think about what these months are. Which one should we do next? We got a lot of time here. We could just do the next one next. Oh, we already did that one. We did that one. We haven't done this one, though. This one's a tricky one. I won't get it wrong, though. This one is a tricky one. Drop those questions in the chat. Stat 201. Chapter 4 quiz. In a way. Boxplots. So in a way, boxplots are the opposites of histograms. A boxplot's always going to show you the 5-number summary. You're welcome, Jaden. Good seeing you here. Anytime. Love seeing you around UT, man. And so histograms are going to show you a better idea of the shape of the data. Boxplots are going to give you a compact 5-number summary. And what people don't realize is when you get a boxplot, the amount of data contained between the lines is going to be the same whether you go here to here, here to here to there. As in, within this region right here is the same amount of data between here and here. And why is that? Crowd management? Yeah, I'll steal one next, Aaron. You got it. Why is it the same amount of data between here to there and there? Explain, because this is the what percentile to the what percentile, just like this is the what percentile to the what percentile. Why is it the same amount of data in those highlighted regions? Like this, there's the same amount of data. If you were to try to like stack these bars up right here, they would stack up just like that bar over there. So why is it the same amount of data within those highlighted regions? Also, you can see the skew nature of the Monster Man right here. So why is it the same amount of data? What do boxplots show you? The 5-number summary. So what's here to there? What's here to there? So use this down, be like, oh, Brian, this is the blank to the blank. This is the blank to the blank. See if anyone gets it. We're doing some deeper understanding with what you should know. What is the lowest number in a box plot? Kind of, Aaron, you're on the right track. This is the 0 percentile, which is the min to Q1, which is the 25th percentile. This is the 75th percentile to the 100th percentile. And this is the median, which is the 50th percentile. Notice how between 0 to 25 is 25% of the data. Like if you think about it logically, it's going to be the min to the 25th percentile, the 50th to the 75th, the 100th percentile. And do not think that this is the 100th. That's just the highest point. That's not an outlier. This is the min, which is 0 percentile. So if you notice right here, 0 to 25% of the data is contained between these two lines. The more spread out the lines are, the more it can tell you it's skewed via box plot. So that's what this question basically goes over right here. And then we'll do the crowd crush thing. Yay, fun topics here. Okay, so it wants to know first, how could you tell by looking at a box plot where the tallest bars would be located? It's going to be where the lines are most closest to each other, and it would be the areas in the box plot where the two vertical dividers are closest together are going to contain the tallest bars. Oh, wait, cancel. So that's because when we look at this right here, we can see the two lines being closest together indicate concentrations of data, because 0 to 25% of the data is contained right there, but 75 to 100th percentile of the data are contained here, more stretched out. So the areas in the box plot where the two vertical dividers, there and there, are the closest together contain the tallest bars. So the max is always the highest end of the graph. True. Exactly. It could be a whisker or it could be a dot. So in some instances, it could be just a whisker. Like if we did not have outliers, then this would be the max and you wouldn't have the lines right here. But if there was no outliers, this would be the max right there. And the max could be, technically, it could be this. There are box plots that look just like this, where that's the max. It's just the 75th percentile and the max would be in the same spot. Does that make sense? So it's possible to have data that looks like this, where the 75th percentile and the max are in the same spot. Data that looks like this is going to be where you have a maximum that is not an outlier. Data that looks like this is where you have a maximum that is an outlier. So it just depends on how your data looks. If you have maximums that are outliers, if you have maximums that are not outliers, and you can even have the craziest situation, I'll draw this really quickly, where you have a box plot that looks like the following. So we just need to look for whiskers, outliers. Yeah, exactly. Look for the whisker. Nice, great answer. What is the maximum of this data right here? What is the max of this data? And then look at the box plot. That's the box plot. The max of this data is 0. The min of this data is 0. And so what's going on right here is that all the data points are in the same spot. So your box plot is just a line. Does that make sense? So if you can't see it, the box plot is just a line right there, because the min, the max, the Q1, the Q3, and the median are all in the same spot. So that's where you get to sometimes these values overlap. Like if the Q1 and the max are in the, or the Q3 and the max are in the same spot, your box plot will end up looking like this, where Q3 and max overlap on top of each other. It just means your data is compact in that area. So your data would just be all jammed right there. So really good questions and higher level questions about like what if it looks like this? And then next one right here. Explain how both the box plot and the histogram can indicate a skew nature. Well, the histogram is really easy to tell with the way it's pulled out. The box plot indicates a skewed because there are outliers in the right tail. The histogram indicates a skew because there are small bins on the far right. Kind of, yeah. The box plot indicates a skewed distribution because the min, the first quartile, the median occur within a small range, while the spans between the median, the third, and the max are much larger. That's great. The histogram indicates a skewed distribution since the taller bars are on the left side. Yep, that should be good right there. So once again, these are compact. Q1, or excuse me, min, Q1, median are more compact. Then median to Q3 to max are more spread out. And then the bars right there. Identify one feature of the distribution that the histogram shows but the box plot does not. Yeah, I'll talk about that next, Tara. We got one more question for that, and then we'll do that next, Tara. The histogram really shows the shape better, or the little peaks right there. The histogram shows the distribution is roughly, the histogram shows that very large number of values occur in the smallest bin. No, they both kind of do. The histogram shows the location of the median. It does not. The histogram shows the presence of outliers. No, they both show outliers. Yeah, you got it, Nemo. We got 3 things. You got it. This diagram shows the distribution is roughly uniform. Maybe it's this. I don't like that one. Identify one feature of the distribution that the box plot shows. The box plot shows the location of the median. I'm a little worried about question 3. I got it right. Yeah, that one's weird. The histogram shows a very large number of values. It's easier to see the tallest bin, and you can kind of tell down there, but not as much. Didn't love this one. Got me a little bit worried. Histogram doesn't show median. Box plots show median. So really good stuff. Nima's got one for us to do right here. We did research innovation. Oh, no, it's Aaron. Crowd crush management strategies. Little small ones right there. Outliers. Frozen pizzas. There we go. Ah! Is this the one right here, Aaron? Is this the question? There can be some that are very similar. crowd management strategies. Okay, let's do it. Crowd management strategies account for rock accidents. In their database, they list the names of the victims and the crowd crush at rock concerts, which be very careful of. It's scary, it's real. And so here is the age of the people in a histogram. We can see the outliers, the old 42-plus-year-old person like me. And there they are over here, indicating they're closer to about 47 years old. This person right there was closer to about 35, 36. And they're outliers. They are very old for concerts, apparently. And then we have individuals down here at 12 years old, and you can see them here in the box plot. You can see the median of about 18 years old. You can see the Q1 of about 16 and the Q3 of about 21, 22. And then the top before any outliers is about 28 or so. Let's see what they ask. Which features of the distribution are seen in both the histogram and the box plot? Well, the distribution has a little skew to the what? What way is this monster man going? This will help us narrow it down very quickly. What way does this monster man go? Right to the high, left to the low, whatever way the monster man's tail goes. Can't get it wrong if you know that. So it's right skewed, and so now we have it skewed to the right. We eliminated one question. With two high outliers at 36 and 48, and we notice that over here, so we can see it in both. And most victims are between what? 16 to 24 or 24 to 30? What are most victims between? 24 to 30 or 16 to 24? 16 to 24 or 24 to 30? What are most victims between? Like the commonality of victims. It might be easier to see over here. Most people at ages between what and what? I would say 16 to 24. And that should do it right there. And what features of the distribution can be seen in the histogram that can't be seen in the box plot? The histogram is going to show better shape. So we see this little bump right here around 22. I think that's what they're going to talk about. We don't see that over here. You're going to see more with the shape. We would not see the median or we would not see the IQR. So we can limit these because these are only seen in box plots. Those are part of the 5-number summary. The slight increase, yeah. The shape, the slight increase right here would be seen only in the histogram. What summary statistics would be chosen to summarize the center? Look, don't even look at their answers. It's right skewed. Don't even look at their answers. It's right skewed. So what should you use? Don't read any of this. It's right skewed. There's outliers. So what do you use? Don't look at their answers. This is how I do it on a test. It says, what is the appropriate measure of center? And you're like, oh, it's skewed. So I should use what? Remember, it's skewed. So use what? The median. So the appropriate measure would be the median. We've narrowed it down to this and this. And because of the skew. So we know because of skew, use median, boom. What would be the appropriate measure of spread? So remember, if we use median, what do we use with the median? So what would be the appropriate measure of spread? And so it's skewed. We used median, and the appropriate measure of spread would be what? Good review stuff right here. The IQR, great job, Bailey, right there. More points. So the IQR would be most appropriate because it is skewed, and I think we've done it, and we're good to go. Another one done. Good stuff. Good questions. Great stuff. Great job, Aaron, right there. We have Tara asked, what is the easiest way to tell if there's a relationship? Let's go look at that. And so Mosaic plot relationships. So I always like to do this example here where I talk about your tests and people passing and failing the tests. And so let's go right here. And we have the outcome of a test or grade. And let's go here to, and then we have version. And we go here and go play. And then we have frequency. Count. And we go here and go 80. Whoops. Good. And now we go to pass on A. 80, 80, 20, 20. Okay. So we're going to analyze this with a bivariate fit y by x, the grade explained by the version with the count right there. And with this, we're going to put it side by side. And I want you to see the data. Okay. And with this, take a look. What would the rock say about taking version A versus version B? What would the rock say about it? Like you want to take either version A or version B of the test.
It doesn't matter.
Will we need to know? You won't need to know how to use it for tests, but it won't hurt. And it's basically, you will look at graphics. So you need to know how to read statistical output, but you won't need to know how to really use it. And it doesn't matter because your grade on either of them as an aggregate, like what students got, they passed or failed about the same on version A versus version B. But now let's take a look over here to see what happens if I say maybe 160 students passed this. Now, if you notice, the marginal distribution got larger for A because there were more students who took A. So as I increase the amount of students who passed this test, you notice it gets wider, but also the proportion of them who passed is also higher because there were more students who passed out of the students who took it. 240 students passed out of the 260, only 20 students failed. What if version B is some sort of makeup test and 80 students failed? Notice more students took it, so the margin got wider for B now because there's more students taking B. You can still see more students took A, about a 2-to-1 ratio. And we could even go down here and look at the columns, and we'll remove out extra information for the moment. But if you go and look at the amounts on the outside, you can see there were 420 total students who took the test, 260 took A, 160 took B, and then we can see up here a visualization of it. Now here's the thing. 50% of students who took B passed, 50% of students who took B failed, and down here, only 7.69% of students who took A failed. And we could calculate that by going into the amount of students who took test A, and we could say only 20 out of the 260 failed. Does that make sense? This would be conditional. Given you took test A, what's the probability you failed? And at this point, I think there's a relationship. The bigger the gap in the conditional distributions, the stronger the relationship. Does that make sense? The conditional is those who took B, those who took A, and you can even compare it to the marginal, which is everyone's pass-fail rate. So if we look over here and we could say 23.81% of all students failed, which would be calculated by going here and doing 100 divided by 420, and we get that 23.8. So 23% of all students who took the test failed, but only 7% of these students failed over here versus 50% of these students failed, and the margin shows us of all students. So you have to think, how big are these differences? And at this point, this is a very large difference between the marginal and the conditionals. And then the smaller these differences, we can go make these small again. I'm kind of doing pullouts from them right there, or pop-outs. And with this right here, we could have less students here. Notice it changes. And then we could have less students fail version B. And now these are smaller differences. So this is a less of a relationship. Does that make sense? This is less of a relationship right here. As we pull the data away from it and we look at it and see what's going on with it, it lets us see that there's a weaker relationship here, and I can make it even weaker if I do this, where now there's very small differences between of the students who took A, what percent failed, of the student took B, what percent failed, what percent of all students failed. And you should know how to calculate this from the table down below. Like any number I show you right here, whether it's like what percent of students took version A, what percent of students who took version A failed, you should be able to calculate these. And the bigger the gap right there, the stronger the relationship. So a bigger gap between conditional distributions, the stronger the relationship is in the data. So really good question. And we got another chapter 4 quiz to help travelers know what to expect. Let's find out what travelers are going to expect. Got time just for a few more right here. Chapter 4. And to help travelers. It's like there's a Vampire Diaries thing. To help travelers. Ooh, the slalom one. Sugar. All these great questions I've done. Uh-oh. Must be earlier. Oh, that's a tough one. I have to re-timestamp this. Was this the egg price one or something? Here we go. It is. It is. It is. I remember. Okay, to help travelers know what to expect. You're welcome, Tara, and great questions right there. I'll show you some points. Thank you for asking. So, once again, we're looking at some side-by-side box plots right here between water, eggs, and bread. And they want to know, in general, which commodity is the most expensive. So we're probably looking at the median right here, which is going to be on average, or the median, which is the 50th percentile, is eggs. It says on average, a dozen eggs is the most expensive of the three. The median price of eggs is higher than, yeah, so we would say it's probably going to be eggs. A box plot cannot be used to judge which commodity is the most expensive. The box plots does not show how many of each commodity is in each quartile. Yeah, but it's saying like in general, and we can compare. I'm pretty certain on that. These prices are for the same countries, but can you tell whether eggs are more expensive than water in all countries? And this is the one that always gets me, and I'm double guessing my double guessing. So I always say no. You cannot tell whether eggs are more expensive than water in all countries. They overlap. You can't tell because it's these prices are for the same countries. But can you tell whether eggs are more expensive than water in all countries? No, you cannot tell whether eggs are more expensive than water in all countries. The box plots do not show how many of each commodity is in each quartile. That's not the amount. It's pretty much because they overlap, and I swear they're going to be mad at me again. Good. I didn't double guess my double guess. It's because you don't know the pairing of these, and they don't state it right. So once again, we don't go as in depth on these questions as you see right here on the test. You see right here two outliers that are at least 1.5, a number you should know. 1.5 IQRs above Q3, 1.5 IQRs above Q3. There are no really low outliers. And man, I wish there was some eggs for less than $1 or water for 20 cents of water. You go buy a water now and it's like $3 for a bottle of water, and you're like, really? We're going to be selling air now? Probably are selling air. And here's the other one. We'll try to do this other one right here. In general, which one is the most expensive? And we see eggs again because they do have a high median. The median for eggs is very high right there. So that is going to be the in general. Is a carton of eggs always more expensive than a bottle of water? So a carton of eggs right here. And I would say it's not possible to tell. It is possible to pair up the data so that it is true and untrue. As in, if this country went with this country and vice versa, if they all like lined up, it could be that eggs are always more expensive. So, but it could be that this country pairs with this country has expensive water, but has cheap eggs. So it's not possible to tell because you could be like, well, it could be the min egg price is the high water price country. So you don't know which way these dots, because there's a dot in here also. We saw a graphic earlier that showed that. You can kind of show it in Jump 2. If you go over to your graph and graph builder and you drag this data into here, you can see their dots and you turn them into box plots, then it's a box plot. So you can tell it's dots inside the box plot right there. And then you don't know which way the countries are pairing up, such that maybe they're paired in a way that it's true or not true. Is a carton of eggs always more expensive than a loaf of bread? Okay. And this one gets me, I think. None of the egg prices are above all the bread prices. None of the egg prices. No, I mean, there are the high outliers of bread prices are above the median of egg prices. Is a carton of eggs ever more expensive? Oh, is a carton of eggs ever more expensive? Yeah. So it's asking, is it the case that in a country you would ever have eggs more expensive than bread? And it has to be, because the maximum, or there are points above the maximum. Yes, there are several egg prices that are above all bread prices. Yes. Oh, it's this middle one. Yep, it's the middle one. It's okay. No, some of the water prices are above the minute price of a carton of eggs. Is a carton of eggs always more expensive than a bottle of water? Let's see here. So some of the water prices are above the minimum price of eggs. So some of the water prices are above. Is a carton of eggs always more expensive than a bottle of water? Some of the water prices are above. I just disagree. Is a carton of eggs always more expensive than a bottle of water? I'm just like, how do they get to this? Man, I hate to end on one where I'm like, what? What, my Pearson? What? So the carton of eggs over here, always more expensive. Some of the water prices, so they're saying right here, there's ones above the min. But it could just be the case that when you pair them up, that they pair up in such a way that eggs is always more expensive. Well, you see the right answer right here. You see where I disagree. And good spot to end. We got a lot of questions done. Oh my gosh. I need some lunch is what I need. Until then, maybe I'll get a Red Bull. Bye for now, everyone. Bye.